So yeah, hello guys. I have been through a lot of things these days. I switched my company and also worked with different uh, projects and like settling to a completely different company was something very not I was not usual of it. So in between these the posting some contest solutions or videos was really very difficult for me, like switching to a new place, finding houses and all. So I got so much disturbed that I could not upload any new videos. So since now I have settled finally, so I can restart the journey. So yeah, so recently I did not participate in the lead code weekly contests. Also in the GFG contests I tried, but I could not make it. I could not participate. So I was up solving the questions, and since these two questions are of just 10 and 20 marks, so I thought let's skip them and just start with the third one. So let's see what's this. It's an interesting question. I came with that. So let's first erase this one and let's go through the problem statement. What is tell us Geek was given an integer x and tasked with count, and your task is to count the number of ordered pairs a comma b where a and b might be different or might be same as well, and the condition is the bitwise OR and the bitwise XOR of both the numbers should be same. So what does it states, if a and b are two numbers, right? So how it should work, if you are aware of the bitwise operations, so a or b should be equals to a XOR b, right? What does it mean? If we observe carefully, it tells us if a and b if we carefully observe the OR operator, what does it give? 1 or 1 is 1, right? 0 or 0 is 0, and 1 or 0 is 1, and 0 or 1 is also 1. And for the XOR operator, what we have? 1 or 1 is 0, and all the rest of the three are same, like 0 or 0 is 0, 1 or sorry, not or, it is XOR. So 1 XOR 1 is 0, 0 XOR 0 is 1, and 1 XOR 0 is 1, and also 0 XOR 1 is also 1. So what we observe here, like these three results are same in both, the last three results are same in whether it is case of or XOR, right? So what we can do now? So here, if you look at the constraints, it is saying that if you consider an ordered pair a comma b, so it must be less than 2 to the power x, right? And you have to return it, of course, modulo 10 power 9 plus 7. So what we need to do, and if you see the value of x, it is up to 10 to the power 5. So let's try it. And for the given examples, as you can see, for x equals to 0 it is 1, and for x equal to 1 it is 3. So let's consider the case as x equals to 0. If x equals to 0, that means no bits are there. And what does it mean? Uh, if you observe carefully, then if some number is 2 to the power, let's say n something, then how many bits it might have? It can have, and let's say some number x is there which is less than 2 to the power n, right? So what do you think? How many bits can x have at most? X can have at most n minus 1, sorry, n bits, right? So if some number x is less than 2 to the power 0, that is 1, so how many maximum bits it can have? It can have like sorry, this is n plus 1 bits, right? Yeah, so it will be having only one bit. So on one bit, what options we can have? Either, so looking at these three options, we can have for every, if it can have one bit, then either we can place at that bit a 0, and also on the other number a 0, right? And similarly for the other ordered pair, if we consider, so we can have 1 and 0, and on the opposite side we can have 0 1, like here it is explained, like 0 0 1 0 and 0 1. So what does it says, like on the same number of on the same bit position, you can either have both zeros or 1 1 and 1 zeros and 1 0, right? Either you can have zeros at both those positions on the same bit position, either you can have both zeros, or you can't just have both ones on that bit position, right? So now let's consider for n number of bits, like it is said that x is less than equals to 10 raised to 5, right? So let's see how it works. So let's say we have n number of bits, right? So how does it work? So if we place at any position, like let's consider n equals to 3, you will be clear. So how does it work? Like if we are having 3 bits, then we have 3 places to fill. Sorry, I don't have my code pen right now, because I have got a new company laptop, and the older one, which was having that editor, is not there. This is a MacBook Pro, so there is nothing there. Like we don't have access to all those things. Or if you guys have any suggestions, like how can I use that online pen or some editing tools, you can suggest in the comments. So let's try to think. So if you are placing a 0 here, if you are placing a 0 on the first position, then on the other side, like to the other number, what you can place on the first position, you can place either a 0 or a 1, right? You can place either a 0 or a 1. Sorry, on the first position you will be either placing a 0 or a 1, because then only it will satisfy these three conditions, right? For the OR and XOR to be 0. So similarly, if you are placing a 1 in this position, on the second position if you place a 1, then what options remains here? It is only left with one option, that is placing 0 here, right? Because you can't place 1 here, because if you place 1 here, then their ORs will be 1 and their XORs will be 0, right? So and so these two are the cases. So at any position, what what all options are there? So for like this position, if you place a 0 or a 1, so we have two options, either placing a 0 or a 1 on the first position and on the second position. So similarly, if we have three options here with us, so we can again put, if we place a 1 here, then what it can be, Like if you go through this, you would be like, it gives us a formula like for let's suppose int I equals to 0, I less than equals to that x that is given to us, and I plus plus, it will give you, it will give you 2 to the power I times 2 to the power I times that combinatorics, if you know. So x c I, okay, and the answer will be sum of all those. So if you initialize your answer as 0, so answer will be sum of all this. Okay, so wait, I will try to explain how this. Yeah, so actually I solved this problem yesterday, so uh, could not get the intuition. So yeah, let's discuss for n equals to 2 and you will get what I am talking about. So let's suppose if our n equals to 2, then what could be your a? So let's take let's take examples of a. So we have to take two numbers and b. So we are considering all the cases for a. So a can be either, if two bits are there, then a can be either 0 0 or 0 1 or 1 0 or 1 1, right? So for 0 0, how many, let's number them as abcd. Okay, yeah. So for the eighth, that is 0 0, how many possible cases are there for b? So b can be either 1 1, right, or b can be 0 1, or b can be 1 0, or b can be 0 0 as well, right? So for all these cases, for this combination of a and b, all the cases are valid. If you see 0 0 1 1, or is 1 1, and XOR is also 1 1. Here the or is 0 1 and XOR is also 0 1. Similarly for all of these. So now let's try to make set examples for b. So for b, what can be the other pair? So for the first position we have 0, right? So we can have 1 0 there, or uh, we can have 0 0 there, right? So these two are the only cases. Any other cases? No. Okay, so for c, what can be, it can be 0 1 or 0 0, right? And for d, what can be the other pair? There are only, I guess, one problem. There is only one option, that is 0 0. Yeah, so in total you can see for n equals to 2, like for 2 bits we have 9 options, right? These 9 options for b. If a, we can take either of these, then these are the examples for b. Examples for another number b. This a and b are the pairs. Let's rename as a and b. Okay, so all these combinations of a and b satisfy this condition that a or b is equals to a XOR b, right? So as we can see, for n equals to 0, it gives us 1. For n equals to 1, it gives us 3 options, which is explained in the example. and for n equals to 2, that is for 2 bits, it gives us 9. 9 pairs are there, right? So as we can observe, this is a power of 3, right? So for n equals to 0, it is 1, that is 3 to the power 0, right? I'm having issues typing on this new laptop. This is 3 raised to 1 and this is 3 raised to 2, right? So from this we can conclude, like, for if we have x number of bits, then this is simply 3 to the power x. So again, for the binary exponentiation, you can take help from this CP algorithm article. So I have used this code, modified it a bit for using modulus. So let's put it here and try to solve. I will just use a modular here, which is 29 plus 7. So I will use the modular operator here. And this does not need a modular. So let's now get back to the code. So let's suppose long answer is equals to bin power, the name of the function. This is 3, this is the base, and this is the exponent. And we return a modular. So let's now return the answer. So this gives the final answer. Let's try to compile. Okay, it is running fine for x equals to 1. Let's try to submit it. Why we are using this binary exponentiation? Because it gives us exponentiation in logarithmic time complexity. As you can see, we try to divide every b by 2, and if it is odd, so it will run in log n base 2 time complexity. Yeah, so that's it for this problem. We'll discuss the next problem in another video. Till then, bye. Thank you for watching.